Hi all, and welcome to November's Edinburgh session. I'm Mike Spencer, and tonight we've got two fantastic speakers. We've got Robin Lovelace, who's at the University of Leeds, and we've got Oren. I have an amazing echo. I'm not sure if that's entirely my fault or somewhere else's. And we have Oren, who is at the Scottish Government. Greg, do you know where that echo is coming from?
I would assume that you have YouTube open somewhere, either the Element client widget or possibly on some other tab.
You are right. Yes, entirely me. I had forgotten. I just grabbed that link.
We'll edit this out.
Entirely my fault. So we have two fantastic speakers lined up, and we're really glad you could all join us. We are live on YouTube, as I have just been stumbling along, and that is being routed through to our chat venue environment called Matrix, and hopefully many of you are already in there. I can see we've got Miriam and Nick who are busily chatting already and saying hello to everyone. So I mean, please feel free to give a shout out and see where folk are coming from. Well, knowing Miriam and Nick already, they might be having a fight off to see who's furthest from Edinburgh. But there's, I'm sure we're getting people tuning in from all over the place. So I'll give it another minute or so, just as folk get tuned in. If you have questions or have connection issues, then please put something either, well, I suppose either via Twitter or preferably in the Matrix chat, and we will do our best to help you. Especially if the video isn't working correctly, but I'm expecting Greg is doing magic things in the background, and all of that is absolutely fine. Nick's saying he's in Cornwall at the moment. Sometimes Nick is in London. He's flips about. It's fantastic having Nick here. Actually, he has just taken over as the OSGeo UK chair. So I suspect, yeah, he's tuned in to see if Robin's got anything to say about maps and spatial, which I'm kind of hoping for. So yeah, I think I'm really looking forward to that. But yeah, great to see Nick here and to see cross-community engagement.
We've definitely had a few viewers from like Canada and things on some occasions, and during Coding in the Open, we had quite a far-flung audience. So we'll see where that goes. Come on, people! If you're further away than Germany, we need to win this.
Oh, and I suppose thinking about our last session, we had a speaker from South Africa as well. So same time zone, but different hemisphere.
Oh, well, she's still in the room as far as I know. Hopefully she'll be around tonight. While we are waiting, should I, do you want to do the Matrix thing once we've got started so everyone knows how to interact? Are we going to hang back on that?
No, I think you go for that now.
Okay, then, okay, all right. Yeah, we've got at least 10 viewers. That'd be fine. So yeah, as Mike already said, we are using Matrix for our chat, and I can see lots of things going on there. In terms of interacting with the stream and the presenters tonight, you have got our lovely new QA bot. So if you have a question, you can either write a message that starts with QA bot, as I will demonstrate in chat in a moment, but you don't want to hear my noisy keyboard. Or you can just ask your questions, and myself and Federico will be keeping an eye out, and we will mark them as questions as well. If you see us put a little eyes emoji on your comment, then you will know that it has been marked as a question, and then Mike will be able to relay those back to the speakers at the end of the talks. So please do use the QA bot. It is very quiet. It won't like say anything because I don't want to spam the chat with constant like acknowledgements of questions and things. But trust me, it does work, and we'll hopefully have a good time with that. It's a new idea over last time when we really struggled with the QA. Other than that, please liberally use chat away amongst yourselves. You're not interrupting the speakers. You're not disrupting anything. It's good to see the community interacting with each other, and I will definitely be chatting away once we get started. Thanks, Mike.
Fantastic, thank you. So without further ado, I'm going to hand over to Robin, who entirely on par for R has come up with a fantastic pun for his talk title. So take it away. Thanks, Robin.
Awesome. So yeah, thanks a lot for setting this up. I mean, this is like stepping into the open source utopia where you've got Jitsi, they've got their own chat stuff hosted. So this is a great thing to see, and I'm really happy to be using all of these open tools, not only to do the research but also to present it. So I've had a bit of prep before to use the tech, so I'm just about to share my screen, and you should now be able to see my slides. So the pun that Mike mentioned is DecaRbonisation. So I'm assuming everyone can see my slides. Let me know if there are any issues with that or with my voice. But other than being a bit croaky because I've got a slight cold, it should all be working fine. So yeah, let's get on with it.
That's great. Thanks, Robin.
So yeah, I'm going to talk a bit about how I think open source software can solve climate change. That's quite a big aim, and it can certainly make progress towards the solution, or at least reducing emissions in the short term. I really do think that there's a link between the two things that hasn't been discussed previously. And I'm going to have a bit of a case study about tools and how the fact that the tools were based on open source software has helped in their ability to inform policies for the decarbonisation agenda. And I'm also going to get a bit more philosophical as well, and talk about open source software in the grand scheme of things. So it's going to be quite light on code. So sorry for any hardcore R users who are hoping for a long live demo, which is often the kind of thing that I do. So I'm going to introduce myself as well. So my job is working at the University of Leeds as a researcher. My official job title is Associate Professor of Transport Data Science. So basically using data science to research transport systems, and specifically to try and inform policy. So I'm the lead developer of the Propensity to Cycle tool, which is a nationally scalable tool for strategic cycle network planning. And I've been told off before for using the word nationally scalable to an audience outside of England. So apologies, because it's not still available in Scotland. And I actually want to use this talk as an opportunity to try and build momentum to right that wrong. And because it's based on open source software knows no boundaries. So it can be used internationally, and there's definitely a movement towards internationalizing that specific tool. I'm also a keen R user and builder of some R packages, and author of Geocomputation with R, which is a free and, well, it's an open source book. It's free to read online. You can buy a hard copy, and we're currently working on a second edition, which should be available at some point in 2022. So if you've ever thought, oh, why is that like that? Now's a great time to contribute. So yeah, that's a very simple summary of some of my R outputs in visual form. The ST Planner package was my first package, really, and I've learned so much since starting to develop the package. And one of the main things that I think the audience of this event will appreciate is this idea of modularity. So when I first started that, I saw packages as like all encompassing, it needs to do everything. And then I realized that creates a lot of technical debt and makes it hard to maintain. So over time, I've been trying to chunk things up, bits of code, being more modular. So a good example of that is Stats 19, which does one thing, and it does it well. It downloads road traffic casualty data that absolutely does include Edinburgh and all of Great Britain. So if you're interested in road traffic safety, for whatever reason, that might be of interest. And then holding it all together is geographic data analysis in R. And yeah, the way I got into this was simply figuring out how R works myself, occasionally writing about it, and then finding that there was interest in this. And that's basically just escalated from there. And we've got this ongoing book project that we are in the process of updating. So that's a bit about me. I'm from Hereford. I'm very interested in the environment. So I did environmental science at York, and a very brief history of my interest in R. Basically, I got into it in anger during my PhD because I just couldn't solve problems that I was needing to solve in terms of representing, modeling future scenarios of energy use for commuting. And I realized that the existing tools that I had, which basically were Excel and QGIS, couldn't hack it. I was told to use Java, but I couldn't figure out how to use Java for that. And I just happened across some R code that someone based in New Zealand sent me. And I'm eternally grateful to that bit of script that I was sent. That was an absolute lifeline to me. And I basically just started writing loads of code that helped explore scenarios of potential scenarios of future. And that led through a long story to a book called Spatial Microsimulation with R. It's probably quite out of date by now, and there are probably better ways of doing it. But that was how I really got into writing code. At that stage, I was only really writing one-off scripts that run once, and then you hope when you next run it that it works. But these two next points are kind of the wrong way around. So I became the lead developer of a government-funded tool for informing policy. And then it was at that moment that I realized that I needed to take programming more seriously. So I signed up to Colin Gillespie's advanced R courses and enjoyed it so much, we ended up writing a book together. And since then, I've been getting really interested in the R spatial community. And I also have loads of papers out as well, but that's a different matter. So yeah, that's a visual summary of some of my work. And basically, these are just teaching materials that I found useful for myself and converted into book form. So I find it so inspiring how the community shares information and basically wanting to give back. So of those three, I would definitely recommend checking out Geocomputation with R. The other two are probably slightly out of date by now. So I do have dreams of updating efficient R programming so that we can do up-to-date benchmarks, but it hasn't been well maintained. Whereas Geocomputation with R, we're actively working on it. So check that out. And that book is most relevant to what I'll be discussing in the rest of this presentation. So my big point is that geographic methods, data science in general, but if you want to talk about actionable policies, usually those policies, if they're enacted at a national level or an international level, that's fine. But for many sectors, whether it's farming and especially transport, the interventions will happen at a local level. So you can't just say, oh, well, this is our policy, this is what we're going to do, and assume that it's going to work the same in every place. There's always going to be a geographic component to that process. And that is a kind of broad concept that is running throughout my work. So the propensity to cycle tool is an example of this, where you have a national target, let's say doubling cycling or getting to Dutch levels of cycling. That doesn't mean that you're going to have the same, you're not going to get uniform levels of cycling across the whole country. You're going to get cycling concentrated where there's most latent demand, and the same applies to infrastructure. If you just spend investment equally, you're not going to get the benefits that you need. And yeah, I've been doing a lot of this kind of stuff. So it's using these geocomputational methods with the data analysis component written in R and the geographic analysis written in R, and then turning those into tools for policy making. So I've also done some COVID response work in 2020. We got a request from the Department for Transport to create a tool for informing the pop-up cycleway agenda and the emergency active travel fund. And then most recently, which I'm really excited about, is this ActDev tool. So this is a tool that's in prototype mode. So unlike these other ones which have been deployed nationally, this is still in prototype mode, but that was good because it meant we could really push the bar out in terms of what we can do. So I can do a live demo as well. But there's one really cool bit in here, so I'm just going to show this. So in that bit, you just saw a drone image of a piece of infrastructure, and then that switched into a simulation. And this goes way beyond what I've ever seen done in R. So this was developed by Dustin Carlino, who is a Rust developer and has developed a micro simulation based tool. So I'm just going to show it a little bit more. And the great thing is this is free and open, and you can actually, by the end of this talk, actually have a play with this on your browser. So other things I'm interested in, I think, people often focus on the technological side when they're doing techie talks like this one. But I think sometimes there's an overemphasis on it. And I think a great thing about the R community is the community and how supportive everyone is and inclusive. So I've been trying to do a bit of community building in my own institution, which is ITS Leeds, and we now have quite a few contributors to various packages. So just spreading the info and empowering other people to do it. So yeah, this is just an illustration of some of my domain experience, which on the top graph you have this is like non-geographic modeling, which again R is really good at, which shows a scenario of change where you have a shift in the transport system, but still it's very dependent on the distance. So related to decarbonisation, you can see that in the top scenario, this is like the current situation. And then you have a scenario of cycling uptake, and you can see that car use is being replaced by cycle trips. And I think everyone can agree that would be a much more efficient way of moving around. Up to about 5 kilometers, car use and bike use. Bike use is dominant, but it also highlights the problem that it's really hard to decarbonize long distance trips. And to me, this very clearly tells the story that you need to do more than technological change. We need behavior change, and we need to do not just mode switching, but also destination switching. So we're simply making fewer long distance trips. So ideas, how can we take all of this forward? Well, I mentioned AB Street. This is another kind of screenshot from the tool. And what's totally mind-blowing, I think, about this tool is that you can not only modify scenarios of behavior change. So in the previous slide, these two graphs represent people changing their behavior, but you can actually go in and edit the infrastructure. And if we're talking about imagining a zero carbon transport system, this is hugely powerful because you can make the edits to your road network. You can use it to make the case for evidence-based change. And I'm relating this here graphically with the evidence on mode shift during the pandemic. So during the lockdowns, you had a massive boom in cycling, and now that's basically back to pre-pandemic levels. But I think that we can use that going forward. So moving quickly on to the elephant in the room. So there's the elephant, and feeling a bit hot there. So I think now is a good time to be talking about climate change, hopefully, even though COP is already off of the news, it's still very fresh in my mind because it is a huge challenge facing us. And I think that data science has a huge amount to offer, and open source software has a huge amount to offer. And in the very kind of broadest sense, climate change is defined by science. Like we know about climate change because of scientific analysis. And I think it's important to think about polarizing issues such as climate change in terms of objective information and making sure that everyone who's talking about it is starting from the same page. And graphics like this really help understand what's going on in terms of the emissions. And the broad point here is that data analysis can contribute massively to the public understanding and also of where we need to get to. So this is just another visualization that shows if you want to tackle climate change, you need to tackle the energy issue. And energy is used in many ways. So often people conflate energy with electricity, but that's simply not the case. So transport emissions, which is still, despite gradual uptake of electric vehicles, dominated by fossil fuels. So that's just making the case for thinking about our energy use. So if you think about this graph in terms of energy use, how can we turn things around? And there's loads of open data sets there. So this is obviously created with R, and the fact that it's interactive can really help people understand it. So I've got an example, which I don't think this was created with R, but I think it's such a great infographic that I wanted to include it on a talk about decarbonisation. Like this one graph shows the scale of the challenge that we're facing. We need to get to, this is the graph that is, I think, Paris compliant. So broadly compatible with a probability of staying within 1.5 degrees C. And it is really a big challenge. Like this represents very clearly, once you understand it, transformational change in the economy. So yeah, and a good way to summarize that level of change, these curves are about in the region of 10% cuts in CO2 each year. So the amount of reduction in CO2 production and energy use during the lockdowns, we need to continue that every single year. And the thing is, it gets harder after the first 10%, after the first 20%. So I think that's, quite a shocking and compelling graph for action. So this is where I go a little bit philosophical. Like, what's actually driving climate change? Well, you can understand it in various different ways. Obviously, it's a complex system with human and environmental factors. But I think, in a way, climate change is driven by scarcity, or at least the perception of scarcity, which drives fear, which makes people feel that they need to consume more of whatever it is, which causes emissions. And open source software can kind of overcome that by providing a feeling of abundance. When you go into the open source software ecosystem, you have all of this stuff, and it makes you realize that you can do almost whatever you want, at least in the data science context, with minimal requirements. And there's a self-supporting community. So I think when it comes to the social changes that are needed to tackle climate change, open source software has got a lot to offer, and the R community is a great starting point for that. So there we go. Open source software can massively help not just in terms of analyzing the data and doing the research, but also in the mindset that is needed to have a low energy future. So I know time's going on, but let's just think about why open source software can be useful. It creates a sense of abundance, as I said. It's super energy efficient compared with Windows, for example. Generally, it has many people's eyes on it. So a big problem in society in general, and this transcends climate change, is reinventing the wheel. So people doing the same thing over and over again. Whereas when you get into an open source software mindset, you realize that actually you don't need to do something that's already been done. You can just build on it and do something new. And I realize that in a way, that's exactly what I've done with my R packages. There's already a great spatial ecosystem, but I realized that there was a need for tools that were focused on transport planning. So I just built on those tools. And that's a really great way, an empowering way, and an efficient way, and a future-proof way of thinking. So that's how open source software can help tackle climate change. So that's quite a big claim, but I think I've got some evidence to back it up. So I did say to Mike when I agreed to do this talk that I would include something from Edinburgh. So at the moment, there is no national cycling uptake model for Scotland that's publicly available in the way that it is for England and Wales with the propensity to cycle tool. But I have actually done some work for Edinburgh City Council via Sustrans that is focused on exactly this question of how do we get more people cycling? How do we enable uptake cars to be replaced by active travel, which, by the way, is also healthier and conducive to socially beneficial outcomes, let's say. So, yeah, I'm just going to demonstrate this. So a lot of my map results, a lot of my outputs are in map form. And I think that's great because you can kind of zoom in. I don't know Edinburgh particularly well, but it gives you a handle of what the cycle network could look like. So this isn't public yet, but we are hoping that we'll make this publicly available, just as the propensity to cycle tool is for all of England and Wales. And just to give you a sense of the scale of this, if we go to the cycling flows and the LSOA, we've calculated cycling potential down to the route network level all across England and Wales. And it would be relatively straightforward to do this for Scotland. So I am in conversation with Sustrans and other people about making this happen, but based on the open source, community driven way of doing things, I'm totally up for talking to people if there's anyone listening who wants to help make this happen for Scotland as well, get in touch. So yeah, that's something about Edinburgh. I don't think I'm going to go into the details of how this works, but I do have a good link for anyone who wants to get started with the using these kind of open data sets to model transport systems. So if you're more interested in the infrastructure side of things, this is a really good place to start. So you can download route network level data and data from OpenStreetMap and start analyzing that data. So I'm sure we can share a link to that. And if you're more interested in the behavior change side of things, I recommend checking out the PCT R package. And we actually have recently improved vignettes on doing that. And then the final thing that links to what I said about not only being able to represent scenarios of behavior change, but infrastructure change is AB Street. So I'm just going to show an example here, and apologies again, this is England focused, and this isn't out of design. This is just because we have more easily, readily available data for here, but anyone can look at a simulation for a specific place using this A/B Street. And I do find it really amazing that you can run this from a web browser. So I'll share that as well. And you can look at a simulation and create scenarios of change. So the final technical link, and again, I'm not going to go into a live demo, but check out the A/B Street R package. So whoops, it's not currently on CRAN. So check it out on GitHub, and you can get that from, it's actually A/B Street GitHub. So yeah, apologies for that link here, and I'm just going to go back to the slide. So yeah, that's what I would say in terms of getting started. So these two, PCT and A/B Street, are great packages for getting started. Obviously, we need to do some maintenance work to get it back on CRAN, and I know there's been loads of changes happening there. Recently, I had the ST Planner package taken down at quite short notice, which is now back up. But you can get it from GitHub, and that enables you to get data, open origin destination data, and create simulations on the map, which can be really powerful. So hopefully that's been interesting. I've covered a huge amount of ground. I've got fairly philosophical, talking about the links between open source software and climate change. I think this is an important topic, and it's great to have a forum to think about it. And you can use this software to build evidence, even if you're not working in the field. As obviously it's my job to do research into transport systems, but you can start playing with the data and talking to other people about how the future could look based on the evidence using that. So I think that's a good place to end. Any questions?
Thanks so much, Robin. And I completely agree with you. I think one of the fantastic things about open data and open source software is that anyone can get involved and be able to interrogate and work with information at a professional level. And I think that's fantastic. And we certainly see that kind of engagement within Edinburgh. And maybe it's just a particularly active community, or maybe it's to do with it being a capital city, or like we all love to believe that the place we live is better than everywhere else, but it just is. No, there's lots of engagement and drive there, and I think that's absolutely fantastic. I am going to have a look at this bot that Greg has set up and see if I can get it to tell me about questions. So Federico asks, how difficult would it be to scale that up to the point where we can generate evidence to inform policies? I presume it means sort of automatically, that could we click a button and it would generate a report and send that off? I'm extrapolating here, but maybe in the same way that you can write to your representatives, be that MPs or MSPs, in a fairly generic way.
Yep. So yeah, I mean, I think to some extent what we've done is put evidence out there. I think what I've done so far is quite one way. It's like, here's some data and here's the results, and then you put it out there and make it available in an interactive format, and people can and do use that in ways that maybe you wouldn't expect. So with the PCT, I've heard many examples of both. So the target audience with the propensity to cycle tool is professional transport planners, and they do use it as a kind of foundation. It's not the most advanced data because it's based on the 2011 census, but it's very much the kind of foundation that gives the the overview of the network. But there's also tons of stories, and I probably have only heard a fraction of them, of campaign groups or just people interested in it who are using the results from this tool to advocate for something that intuitively they think is it. For example, if they think a cycleway is needed over a bridge in a particular place, they can go to the PCT, take a screenshot of it and send it to their councillor. And that, I know that is being used to a large extent. I think a limitation with that approach that we did is it's very, very static. So all of the analysis is done in R. You do it once, you generate the geographic outputs, and then you serve the files in, I think, like a relatively dynamic map. What I think the question is alluding to is, can you dynamically change the simulation in real time? And can you make that available? And the answer is not using the PCT approach that I've used, but you can do that with the AB Street software that I mentioned. So AB Street allows you to edit the network. It allows you to change the travel behavior in real time. It doesn't have the same kinds of scenarios that we have in the PCT. And I'd say like that's not its aim. But if you create an interface to the kind of high level modeling, which you can do in R, and then you put the outputs to AB Street, you can actually have both sides of the interactivity. So I think it is actually possible now. And I'd say check out AB Street as a project. It's really powerful. And if you want to access it from R, the AB Street package that I talked about is a good way to start.
Fantastic. We got a comment from Marion about using OpenStreetMap data, and she's particularly phrased it around potholes not being, I suppose, a data type that people could log. I'm aware there was a talk about pedestrian data at Phosphor-G a few weeks back. I haven't had time to catch that yet on YouTube, but I wondered if there's, sort of, if you've got thoughts around potholes or other data that could come from OpenStreetMap that would be useful.
So yeah, I think it's, to some extent at this point in time, it's more of a social problem than a technical problem. So we have platforms where people can upload data, but the truth is, when most people see a pothole, they don't go and report it onto the Open Data Commons. I mean, obviously some people do, but I think if we, people who are doing in education and at high levels in government encourage a more participatory approach to reporting issues and an open data approach, we can have that. And I think OpenStreetMap could actually be used. I mean, it would be a bit of a hack of OpenStreetMap, but I believe you could actually use that as a pothole reporting mechanism. As it happens, I'm working on a project with someone in the Leeds Institute for data analytics, who's looking at how much you can use OSM to inform active travel. And she's focusing not on cycling, but on accessibility and walking at this point. And I think it's early days. Like we had a look at tags in West Yorkshire for wheelchair access. And in fact, there's very little data. So I think there's a data scarcity issue. But the great thing is there's like thousands of potential contributors to this. So if we harnessed that need for people to feel like they're participating in society, you've got like a very powerful and adaptive data collection mechanism that also happens to empower people. And so I think that's the way forward. So I think OSM could be that project, or there could be another project to do it. But generally, I'd say use the, going back to the point of open source approach, not reinventing the wheel. A lot of stuff can be done on OpenStreetMap. So that would definitely be my first port of call. I don't know if I fully answered the question, but I can send a link on the chat to that project.
Fantastic. Thanks, Robin. I am going to move us on in the interest of time. There are a couple more questions on Matrix. If you have some time to dip in and fire away, that would be fantastic to see you there. So our next speaker is Iris from the Scottish Government, who is going to talk about climate targets. So let's cross our fingers for a screen share and all those kinds of smooth things.
Indeed. Great. Hi all. So apologies firstly for the camera angle. I'm on a laptop with a weird angle of the camera. So yeah, apologies. Great. So let me just put the screen share on.
That's absolutely perfect.
Great. Okay. So yeah. My name's Iris Oren. I am what's called an Operational Research Analyst in Scottish Government. Most people don't know what that is, so you can just think of me as a modeller. That's generally what I do, all things modeling. So what I'm going to talk to you about today is my recent work in the Energy and Climate Change Analysis team. And in this team, we're looking at how we model Scotland's decarbonisation. Okay, so before jumping into Scotland, I'm going to, screen, let's do that. Yes, let's first talk about, is that coming up? Has this changed? Can you see the slide, or is that blank?
We have an imaginary country,
yes.
but
okay.
nothing in it, just white.
Yes, that's the imaginary country so far. So
okay.
Okay, so this imaginary country has various sectors. So we'll call them sector 1 to 4. So they could be, say, agriculture, the residential sector, the energy sector, etc. And each of these sectors have processes within them. And those processes are specific to the sectors. So in the agriculture sector, it could be, transport of that's a particular crop, or so each sector will have its own particular processes. In addition, sectors will have specific demands for those sectors. So for the residential sector, it could be a heat demand. For agriculture, it could be the number of livestock, particular numbers of livestock. There are also then inputs to those sectors, particular commodities that those sectors need. So some of them will be specific to sectors, and some of them will be shared commodities. And the most obvious one that we can think of is the electricity or gas. Those are shared commodities that need to be shared across sectors. So what the sectors do is they take those input commodities, use their processes to make outputs, to produce outputs, which then go towards meeting the demands. And very often, most of those processes will release emissions, and that's what we're interested in. So then our first question is, how does an economy distribute these shared commodities and utilize processes to meet the demands? Obviously, as we live in the real world, so most of those things will have costs associated to them. So the commodities will have costs, processes will have costs associated. So then the key question is how we do all of that, distribute the commodities, utilize processes to meet demands at minimum cost. So now we get one level above that. So I'm just going to remove all the pound signs and just leave one token pound sign just to remind us that there are costs. And the next question is, what happens when, as in the real world, most things are constrained? So commodities could be constrained. There could be a cap on the capacity of electricity generation. So commodities can be constrained. Emissions can be constrained, which we now have climate change targets, so the emissions can be constrained. Processes can be constrained, for example, by capacities. So you can have various constraints across this economy. So now we ask, how does the economy distribute the commodities, utilize processes to meet demands at minimum cost under sets of constraints? And then the last element is, we're not looking at this as a snapshot in time. We need to do this over a time horizon. So how does it do it? You need to solve that problem that we previously described over a specified time horizon. So that's what we're interested in modeling. And the way we do that is we use the TIMES framework of modeling. So TIMES stands for the Integrated Markel FOM system, and that in turn stands for Integrated Market Allocation Energy Flow Optimization Model System. So the aim of the TIMES aims to find the least global cost solution for an energy system under constraints. It's a model that's used, a modeling framework that's used internationally. Most countries will have a TIMES model, which is tailored to their country, to their economy, to solve these decarbonization problems. It's a model of the whole energy system over time, and there are, for most TIMES models, there are tens of thousands of variables that you need to solve over and find the optimal solution. So the model takes inputs information, so the technology information, so for example, current and future capacities, efficiencies of the processes, cost information, takes information about the commodities, so current and future availability, costs of the commodities, and which technologies use which commodities. And then the key inputs are the constraints, so greenhouse gas emission constraints and any other targets or additional constraints that the users of the model, stakeholders, want you to model and meet. When you run the model, it produces various outputs, so it will tell you what technology mixes you need to get this solution over the entire future. So how many wind turbines do you need to put up? How many electric vehicles do you need in a particular year? It can tell you the future costs for this decarbonization that you envisage. It'll tell you the breakdown of commodities used over time, including energy as a commodity. And then the key thing is the emissions envelope. So what is your trajectory going to be for carbon from now until the end of your time horizon? So that's a summary of TIMES. How is TIMES used? And this is a schematic of the way it's traditionally been used. And you can see a whole lot of Excel symbols. So we have, so we have the input data to TIMES. So very often most input data is pre-processed in Excel to produce Excel spreadsheets, which are needed for the model. So those Excel spreadsheets then go into the proprietary software called Veda 2, or what's called Veda, the most recent version is Veda 2. Veda will then process those Excel spreadsheets to produce a TIMES model, which is then processed by GAMS, don't worry about that, which then passes it to optimization solvers. The solution of the solver goes back to Veda. Veda then produces model outputs. I should say, sorry, Veda 2, which I'll demo in a minute, is a graphical user interface. So the outputs of that are produced into spreadsheets, and traditionally those have been processed in Excel as well. There's a slight move to R in that, but mostly Excel to produce various spreadsheets, which are then given to your stakeholders, whoever they may be. So I've divided this this image into what I've called not reproducible and reproducible. So not reproducible is everything Excel-based and using a graphical user interface, and reproducible is a text-based scripting, environment. So basically, all the pre-processing is done not reproducibly, and the interaction is not reproducible, but there is this reproducible element there under the hood. Okay, so I quickly want to just show you what Veda looks like, and hopefully this will work. There's Veda. Okay, so that's Veda 2. And it has various tabs. So I've just loaded one of the demo models that comes with Veda. And what this is each of these names here links to an Excel spreadsheet. So REG PRI's V07 that's spreadsheet. That's the spreadsheet here. And so this is one of the input spreadsheets to this model. And you can see it has lots of tabs. And Veda will read this spreadsheet and all the other spreadsheets to create the information that it needs. So that's one spreadsheet. Each of these is 1, 2, 3, 4, 5, 6, 7, 8, 9, about 16 spreadsheets plus additional ones. So, and each of those will have numerous tabs. So there's a lot of room for error there in data manipulation in data usage. So that's the input data to the Veda model. A useful feature of Veda then is that it processes all that input data and it then creates all these variables. So these are all the processes that you have in your model. These are all the commodities that you have in your model. But a nice feature is what's called the RES, and that's called the reference energy system. And that tells you how commodities and processes are linked. So we've got a coal commodity, which is used by this process DTP-COA to produce that output. If you double click on that, it will tell you what the next element in the list is. Okay, so that one doesn't have a downstream process. But this is a useful visualization that you can actually see how things are connected, how those commodities and flows are connected. The next element is the run manager, and this is where the controls happen. This is where the user says, okay, I want to run this particular combination of scenarios or files. And then you produce, the user would click there, select what they want to run, and then press solve, which I won't do at the moment. That then sends everything to GAMS and the solver, and it produces the results, which can then be, again, visualized in this results spreadsheet, and these then can be exported to Excel or CSV. But basically these tables. So that is how how Veda works. And that's kind of where I came into this. I joined the team earlier this year, and I started getting my head around this. And what I realized is that it disturbed me that this was highly prone to all the results produced by these times runs would not be reproducible between analysts. There'd be a difficulty there. So I started thinking, okay, how do I now make this more reproducible and R-based? Because I don't know how to use Excel. And the easiest thing to do was to make the outputs reproducible. So what I've started doing is just taking the outputs from Veda and preparing markdown reports to produce the outputs. So that was kind of the lowest hanging fruit. The next element I thought that would be nice to do is to try to, instead of getting the results from Veda into a CSV, to get the results from Veda directly into R. So we wouldn't have to use that results sheet that you see at the end. And that's where I thought, okay, this is kind of, I'm going to be writing some functions to do this. This might be useful for other people, so maybe I'll make an R package to try to do this. And I should say that unlike Robin, he's highly experienced in R packages. This is kind of my first foray into writing R packages. So what I'm going to present now is kind of my beginner's exploration of developing R packages and what I've learned from it. So I decided that I'd try write this package, and fortunately the name Veda was available. The name might still change, but it's currently called Veda. So that's the package. So I'll just quickly show you the GitHub page for Veda. So it's not on CRAN yet, as of, obviously this is very early days, and I'm just still figuring things out. So this is hosted on the Data Science Scotland website, and yeah, so I've written, the README includes the basic functions that are currently available, and I'll give you a description of what they do shortly, or some of them. But yes, it's still quite early, and I originally started with just thinking, how do we get the data from Veda into R? But now I've also added some slightly more, some functions that allow the user to directly interrogate the data in R. Because what I'm envisaging is that most people who come into this will not know R. So I'm just writing kind of some higher level functions so people don't have to start, grasping the whole of tidyverse just to be able to use this. So that's the GitHub page. What I'd like to start by talking about is just giving people a brief introduction to packages and what I've learned from developing this package, because I think before I started this, I thought, oh, packages are these impossible things that you need to be an R guru to develop. But what I've learned is that that's not the case. And hopefully someone after this talk thinks, oh, maybe I can try to do a package too, then I'll be very pleased. So what is a package? A package is a bundle of code, data, documentation, and tests that together will give you a collection of useful functions in R that serve a particular purpose. So the advantages of writing a package: it's much easier to share code. It makes you pay attention to package versions, and by this I mean package versions of other packages that you use in your package, which I think is good practice. It makes you think about the functionality of your code and think about what users will need and what can go under the hood. So what are your kind of your utility functions, and what will a user actually need to interact with. It enforces good practice, and I think that for me this has been the key thing. So you have to think about paths, you have to think about file organization, you have to think about documentation, and this is all an integrated process. And then it makes you understand how R treats data and files, and I've just learned quite a bit from this process in terms of that. Disadvantages, not many. There's a learning curve, which is the biggest thing, but I'd say that's a fun learning curve, so I'm not sure that's a disadvantage. And the user-centered design can slow development. So you have to constantly be thinking, what does my user need? And very often I've had to go back and change how a function is called because I've realized this won't be intuitive to users. And that's all in process. So tips, how I learned to start on this journey is I read Hadley Wickham's the R Packages book, and that's available online. And anyone who wants to start on this process, I just recommend going through that. Use DevTools and other packages that are recommended in Hadley's book. So DevTools just makes your life a breeze because it's a high-level interface for all the functions that you need to interact with the package while you're developing it. And then use GitHub and use issue tracking to organize how you incrementally improve your code. So what's different when you write a package to other R projects? So for me, the key thing is that you're thinking functionally all the time. You're not thinking of what is my project going to do. You're thinking, what are the functions that I need to solve a particular problem? You need to think of all the potential users. Now, as I said, Times is used internationally, so it's all good and well for me to develop the model on the package on my data, but I need to think now, how is the international community going to be using this in various cases? I'm sure I haven't released this too widely yet, so I'm sure I'm going to be running into a lot more issues in terms of that. The key thing when writing functions, The biggest difference is that you need to name all packages explicitly. So rather than saying mutate, you'll have to say dplyr and mutate. You need to decide how to organize functions into separate files in a logical manner. And you need to consider side effects in your code. So for example, things like source or library or require, that changes your environment, and you don't want your package to change your environment while it's being used. So you can't use calls like that, and other things with respect to side effects you need to think carefully about. You need to write a useful thing, and for me this has been kind of constant go-to, is to thinking in terms of the vignette. The vignette is going to be used to introduce people to your functions. So this has been it's almost like for me has been my narrative of how I want users to think about things. And I've used that in terms of changing how I structure the functions. You need to document all your objects, and by objects I mean your functions, your data, and the package itself. And for that you can use the Roxygen 2 package, or Roxygen 2 framework, not just the package. And all that means is that in the headers of the function, you format that in a particular way. So for example, you declare your parameters at parameter X, and you have all these at keys. And then the Roxygen 2 will process that into your standard R documentation pages. So you don't need to know any more than that, just how to format that, but be consistent and write all your documentation as you're going along. And yeah, so that's my take on R packages. How am I doing in time? So I'll quickly show you the vignette that I've written so far. Wrong page, there we go. And just quickly introduce you to what the function, what the package currently does. So I've got a bit of an introduction, and the first thing is to get the Veda data into R. So all you need to do here is you provide a file name base. So this is, for example, a demo S001 model, which comes with Veda. You provide that file name. And then I've got some import functions. There's a function called import VD, which is to import the Veda data. There's some additional import functions for other types of Veda data. So I've got 3 functions for importing the different types of Veda data. But then I've got a wrapper function called prep data, which is a call to those 3 and just joins those tables, and then that creates a tibble, which is your entire output in long format of your Veda data. So now this is an R standard R tibble, and you can run whatever functions you want and customize them. So you can then assign sector information, and I've written a function for that, so don't worry about that. We'll ignore that for now. But the key thing I want to show you is to compare the results that this prep data can produce with the results produced in one of those Veda output tables. So I've just shown the users that. This is importing one of the Veda data frames. So I just load the demo results. This is a table directly from Veda. And I compare that to a tibble, the demo 001 tibble that I've created. I filter it for the same parameters, so everything with cost information, and for the sector call. I select the same columns, and then I just show the user that the table, the information is identical as what you would get using the Veda GUI. The next thing, so that's the import part. The next part is talking about the reference energy system, which I showed you in the Veda interface, which you could click through. The approach I've taken for doing that in R is to convert the Veda tibble that I've created into an iGraph object. So this is a network object. And the iGraph package in R, it just gives you a plethora of functions to analyze graph structures. By graph, I mean a connected network. So I've created a function called make graph from Veda data frame. So I take the demo S This is another DecaRbonisation data frame. I filter it for the period, and I run make graph from Veda data frame to create an object G. And now I can use all the iGraph packages, all the iGraph functions to interrogate that object G. So this is, for example, all the weights of the object G, which are returned. I won't go into the details of that, but there are various other functions to interrogate the graph structure. But then lastly, the viewing the reference energy system. So I showed you how you could click through that. What I've done is use the graph information to write a function called makeRes, and that represents the reference energy system in a Sankey diagram. So that these are the processes, and the flows are the commodities. So you can see crude oil goes from import of crude oil step 1 to the refinery. And the refinery sends motor spirit, it sends heavy fuel oil, kerosene, etc. So there are various permutations of the makeRes that I've created. And yeah, and hopefully that will be useful for people to visualize the reference energy system. And I think that is probably me. Yeah, so just closing thoughts. Writing packages is much simpler if you've got dev tools. GitHub is great for, I've found it just pivotal in running an effective workflow. And writing packages is a little bit of extra effort, but it's a lot of fun, so I'd highly recommend it. And that's me.
Fantastic. Thank you, Iris.
I'll stop screen sharing if I can jump to the screen. Okay, there we go. Yeah.
Brilliant. Okay, we have had a couple of questions through, and while my brain catches up with that, I'll definitely be spending some time watching your video again. I keep telling myself I need to write packages and start one and never quite follow through with it. So yeah, so that's been really useful. Thank you. Right, let me see. Greg has kicked us off with a question. Says the example spreadsheets had a lot of formatting, color, etc. Is that a pain to deal with when ingesting data into R? Or perhaps I'm really asking how the needs of the end users drive your input data format.
Yeah, so the input data at the moment, I haven't interacted with it. So yeah, I'm just looking at the output side at the moment. Input data is the next thing I want to deal with. The colors aren't key in processing. What is important is the format, the structure of the data. So you need the headers, and you need kind of a label for a particular table to appear above a particular column in the data. So there's formatting issues there of rows and columns. So it's going to be a bit of a faff, but that's kind of the next thing I'm hoping to do at some time. And I think that's where Robin's point is really important. So at the moment, I've just focused kind of on the output, and maybe it might need another package for processing the input data.
Yeah, I was definitely thinking that as well. So it's this modularization, and actually this is doing that specific task, and this is doing that specific task. Greg says yes. I think he's happy. If other people have got questions, please add them in the chat. In our convener back chat channel of dads, one, I think, can't remember if it was Federico or Greg, made the comment that it's very strange that we're being saved by something called Veda. But it's very much a dad joke type thing. Have we had any more questions in? What have I missed? I suppose I've definitely got one. How are your colleagues reacting to your work?
So far positively. So I've just shared it with So within my team, it's kind of in a small team, and everyone on the team is on board, and it's improved our workflows. So that's been positive. I've just shared it with colleagues in the UK government, and they're starting to test it out as well. And some colleagues, some academics at UCL. And yeah, so there has been positive interest. People are also very interested in now moving the outputs directly into Shiny and creating Shiny dashboards. So this will be nice that it's, now that we're thinking of shinifying everything, that it's, you can just go directly from, you can just do it in a standardized way. I will be presenting this to the wider Times community at the start of December, to the international Times community. So hopefully, watch the space. I think my main point is that I'm excited that maybe other people might want to contribute to it, because obviously there's only so much I can do. I still have the rest of my day job to do. I'm hoping with presenting it more widely that other people will start contributing. And again, with building on more open source. That
sounds fantastic. I suppose that ties in with Robin's experience earlier, saying that tapping into wider communities allowed him to share effort and workload and make things run smoother. We've got a question from David, who asks, is Times itself open source? And if so, could you make a totally open source pipeline?
Yes, so Times is open source. Veda isn't, so Times is. You have open source solvers. Not all the solvers are open source, but most of them are. So yes, there are rumblings under the hood of how this can go, in the future, go completely open source. But I think that's definitely not a one-person job. But people are starting to think about that.
I suppose. So I've got a bit of my PhD in a department with lots of climate modelling, and the parallel there was when the Joules climate model was developed. It was developed open source, so lots of academics and other people could all contribute into the project and use it on what they needed. So I totally agree with you. There's a lot of things that can happen there. I think I am getting a kick from Greg saying we're starting to run over. Please, Iris, come and join us in the chat, because I'm sure there'll be a bit more after the session. I'd really like to thank both of our speakers, and just to remind you all that we have a YouTube channel, and you can catch up on past talks there. But before we sign off, Greg has a few things to say.
Just one, I was just going to say pretty much what you said. If you are watching this on YouTube later, then hi, where were you? But also come and join the Matrix channel, because it will still be there. It's persistent. That's why we're using Matrix over other platforms. You can come and join in the chat and ask the questions that you thought of while you were watching the recording a week from now. Hello from the past. And come and join in. And we'll still be here by this time next month and the month after, and we can keep chatting. It's going to be great. But in the meantime, I will also add my thanks to both our speakers this evening. It's been really fantastic. Thank you both very much.
Federico, do you want to say a couple of things about December? Was that?
I'll just quickly close up by thanking again our speakers and telling you all that we won't be having a meetup next month the way we are used to over the past few months. We are hoping to be able to organize something in person as a means of saying before Christmas holidays or something, for those of you who feel comfortable to do so and are around the Edinburgh area. However, we're still working out the details, because of course we want to do this in safety and so that everybody feels okay doing that. So keep an eye on our Twitter channel, and we'll keep you posted about our plans. And thanks for attending.
Okay, thanks very much, everyone. And yeah, please feel free to keep chatting within the Matrix channel, because as Greg says, it will continue to be there, and we will carry on using it next year as well, I think. So thanks very much for attending. See you all.
Bye. Thank you.
And we're offline.